To continue reducing the cost of solar energy and other clean energy technologies, scientists and engineers will likely need to focus, at least in part, on improving technology features that are not based on hardware, according to MIT researchers. They describe this finding and the mechanisms behind it in the journal Nature Energy. While the cost of installing a solar energy system has dropped by more than 99% since 1980, this new analysis shows that soft technology features such as the codified permitting practices, supply chain management techniques, and system design processes that go into deploying a solar energy plant contributed only 10 to 15% of total cost declines. Improvements to hardware features were responsible for the lion's share. But because soft technology is increasingly dominating the total cost of installing solar energy systems, this trend threatens to slow future cost savings and hamper the global transition to clean energy, says the study's senior author Jessica Tansig. The team created a quantitative model to analyze the cost evolution of solar energy systems, which captures the contributions of both hardware technology features and soft technology features. The framework shows that soft technology hasn't improved much over time, and that soft technology features contributed even less to overall cost declines than previously estimated. Their findings indicate that to reverse this trend and accelerate cost declines, engineers could look at making solar energy systems less reliant on soft technology to begin with, or they could tackle the problem directly by improving inefficient deployment processes. Researchers have observed that the so-called soft cost of building a solar power plant, the cost of designing and installing the plant, are becoming a much larger share of total cost. In fact, the share of soft cost now typically ranges from 35 to 64%. In the past, scientists have modeled the change in solar energy cost by dividing total cost into additive components, hardware components and non-hardware components, and then tracking how these components changed over time. The researchers developed a quantitative approach that models the change in solar energy cost over time by assigning contributions to the individual technology features, including both hardware features and soft technology features. For instance, their framework would capture how much of the decline in system installation cost, a soft cost, is due to standardized practices of certified installers, a soft technology feature. It would also capture how that same soft cost is affected by increased photovoltaic module efficiency, a hardware technology feature. With this approach, the researchers saw that improvements in hardware had the greatest impacts on driving down soft costs in solar energy systems. For example, the efficiency of photovoltaic modules doubled between 1980 and 2017, reducing overall system cost by 17%. But about 40% of that overall decline could be attributed to reductions in soft cost tied to improved module efficiency. The framework shows that while hardware technology features tend to improve many cost components, soft technology features affect only a few. The researchers used their model to study several countries, since soft cost can vary widely around the world. For instance, solar energy soft costs in Germany are about 50% less than those in the US. The fact that hardware technology improvements are often shared globally led to dramatic declines in cost over the past few decades across locations, the analysis showed. Soft technology innovations typically aren't shared across borders. Moreover, the team found that countries with better soft technology performance 20 years ago still have better performance today, while those with worse performance didn't see much improvement. This country-by-country difference could be driven by regulation and permitting processes, cultural factors, or by market dynamics such as how firms interact with each other. Their analysis points to two strategies for reducing soft cost. For one, scientists could focus on developing hardware improvements that make soft cost more dependent on hardware technology variables and less on soft technology variables, such as by creating simpler, more standardized equipment that could reduce on-site installation time. Or researchers could directly target soft technology features without changing hardware, perhaps by creating more efficient workflows for system installation or automated permitting platforms. In practice, engineers will often pursue both approaches, but separating the two in a formal model makes it easier to target innovation efforts by leveraging specific relationships between technology characteristics and cost. In the future, the researchers want to apply their quantitative model to study the soft costs related to other technologies such as electrical vehicle charging and nuclear fission. They are also interested in better understanding the limits of soft technology improvement and how one could design better soft technology from the outset.